Here our problem is using a constant voltage drop diode model at Vd is equal to 0.7 volt. Find the voltage and current indicated in figure below. Here we have to find this current I, ID2 and the voltage across this point and ground. For solving such problems, we have to rearrange the circuit diagram. Here we can see that this section is flipped vertically to form like this. Okay, there's no change. Some rearrange is made. There will be no difference in current flow or voltages. Okay, we have just put this diode and resistor downwards. Okay, now we are just put this vertical diode into horizontal and this diode also to horizontal. This is the change from this figure to this. Now from this figure we have made this is a minus 10 volt. Minus 10 volt means a DC voltage of 10 volt connected minus to the resistor, so automatically the plus will be to the ground. Here a 10 volt positive supply means the DC supply having positive connected to the 10k resistor and negative to ground. Okay, now here ground, here ground, here ground, so these ground points can be connected commonly. That's done here. Now we can see that here we have got two loops. This is a loop, this is a loop, this is a closed two closed loops. Okay, now by solving these two loops we can find out the values of I and ID2. First we have to make the loop equations for these two loops and then solving the equation and find out I and ID2. Okay, before that just mark the current flow direction. Okay, here we know that current flow in this loop is in this way, like this direction. That means current will flow from positive to negative, so we have marked positive here and negative here, since current is flowing from here to here. And in this resistor also from here to here is the current flow, top to bottom. That's why we are putting positive to the top and negative at the bottom. Here in this loop we are considering this loop as this voltage, and the current is flowing from this point to this, like this, that is in anti-clockwise direction. So here in this resistor the current flow is from here to here, that is positive potential to negative. So here we are putting plus and here minus, here plus, here minus. That's same for this resistor, because this current I and ID2 are flowing through this resistor in same direction. Okay, now we can write the loop equations. First we consider the first loop. here we are taking the voltage drops from here to here in this anti-clockwise direction. First we are taking 10 volt, so 10 volt minus, through this 5k resistance there are I and I2. Here is minus to plus, so we are taking this as minus 5k into I plus ID2. Here also minus to plus, that means minus direction. The voltage drop across diode is 0.7, that's given in the equation, in the problem itself, question itself. So we will get the equation as 10 volt minus 5k into I plus ID2 minus 0.7 equal to 0. Okay. Now considering the second loop, we will get 10 minus, minus to plus, that means here we are taking minus to plus as our reference, so this will be taken as positive. So 10, here plus to minus means minus 10 minus 10k into ID2, here also minus, the drop across diode is given in the equation as 0.7 minus current across 5k is 5k into I plus ID2. That's it. 10 volt minus 10k into ID2 minus 0.7 minus 5k into I plus ID2. Here's a supply again, that is minus to plus, so we can take it as positive, so plus 10 equal to 0. Now we are trying to solve these two. Here we can see that 10 volt minus 5k into I plus ID2 minus 0.7 equal to 0. Here is also that something. Here's a 10 minus 5k into I plus ID2 minus 0.7. Okay, let's see. These are the two equations we have got. Now just rearranging. These are taken into separate. This is the same in the third equation. We can see that value of this term is 0, so we can replace this term with 0 by putting this in equation 5. We will get minus 10k into ID2 plus 0 equal to 0. Now taking this to the opposite of equal sign, other side of equal side, we will get a 10 equal to 10k into ID2. So therefore IDT is equal to 10 volt divided by 10k. The answer is 1 milliampere. We have got the value of ID2 as 1 milliampere. Now put this value of ID2 in any of the two equations we have got first, and we will get the value of I. We are putting 1 milliampere in equation 3. We will get 10 volt minus 5k into I plus 1 milliampere minus 0.7 equal to 0. 10 minus 0.7, 9.3, 9.3 minus 5k into I minus 5k into 1 millivolt means milliampere means 5 volt equal to 0. So 9.3 minus 5, 4.3 minus 5k into I equal to 0. Taking this value to other side of equal, we will get 4.3 equal to 5k into I. Now finding value of I, that is I is equal to 4.3 divided by 5k. We will get the value as 0.86 milliamps. Okay, now we are substituting the values of I and ID2. Oh, here this is ID2. Now voltage V can be calculated as the voltage drop across this point, that is this voltage plus drop across this resistor will be the value of voltage across this point. Okay, we know that the value of current flowing through this resistor is 1 milliampere, and we know another thing, that is current is flowing from here to here. That means the polarity will be plus here and minus here. That is, the polarity of the source and the resistor will be in opposite. So 10 minus 10k into 1 milliampere. 10 minus 10k into 1 milliampere, that's equal to 10 volt minus 10 volt, that's equal to 0 volt. The answer is 0 volt. So we have solved the old values. We have got I equal to 0.86 milliampere, ID2 is equal to 1 milliampere, and the voltage V is equal to 0 across this point. Okay, thanks.